Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, everyone. Let's start today with each other about the work. That's a new chapter, chapter 5, section 1, page 154. Okay, if you want to open your book, 154, work. Of course, some of you think about the work when he hear this word, work, he think when you make effort, it will be work. Some of you think that. Most of the terms in this book we are talking about, you can find the same in your life, but work, not like that. Sometimes if your father go to work, of course that's not work we are talking about. If you make effort and think by your mind or like that, of course that's not work we are talking about. Not just that, if we are talking about someone hold chair, look over guys, let me to draw. Suppose that we have a student or boy hold the chair. Okay, suppose that he hold the chair like that by his hand and use his hand to hold the chair maybe for 1 hour. Okay, yeah, what do you think? He make work or not? I will explain that now. Not just it. Suppose that we have another one, another student hold his bag, okay, and move maybe for 1 kilometer, and by holding his hand, his bag. Okay, now what do you think? He make work or not? We explain all of that today. Now in physics, work not be like that. Not all the effort you will make, it means work. No, the work, we have another definition in physics. Work, it means when the force make and displacement. Okay, we can read this part here to understand more. Let me to make it bigger. Okay, now I want someone, please guys, to read the meaning of
product of component of a force along the direction of displacement and the magnitude of the displacement.
Excellent. Yeah, what does it mean, guys? It means that the meaning of work, when we have car, for example, or any object, okay, and we start to push this object and use force. Now we have force and this object will move for and make displacement. Now it means that this boy will make work. Work is product. It will happen when the component of force, it means the force component or the force were parallel with the displacement, okay, along the direction of the displacement. They are the same direction as you see here, and sometimes I will explain that now, maybe they will be in the opposite direction, but anyways, now the displacement, magnitude of displacement, it means when we have force acting on the object, and this object and this force causes displacement, in this case we have work. In this case we have work. Anything else, no work. No work. If there are no displacement, no work, because that this lovely boy hold the chair for 1 hour or more, and he make a lot of effort. In fact, he doesn't make any work. He doesn't make any work, no displacement here. But you think that also this boy, he make displacement. But in fact, guys, this boy also no work. Do you know why? Because here the force will be perpendicular to displacement. The force should to be parallel to the displacement. In this case, no work. Not just parallel. Maybe sometimes we have angle for the work, and with the displacement we explain that now. But anyways, now if the work, if the force perpendicular with displacement, no work. Okay, if there are no displacement, no work. That's the meaning of work in physics. We will explain more about that now, and explain the formula of work to understand more about that. I think that's easy to understand. Let me to explain more about this formula about work. Okay, now work equals FD. When W is work, symbol for work, F symbol for the force, D symbol of the displacement. It means we have object like that, and you will use force to push this object like that. That is a force, and that is the displacement. Now they are parallel with each other, they are parallel as you see here, and that is the work. Now we have work here. Work equals F times D. Very simple, very easy. I don't write that. Okay, yes, very simple, very easy. That is the work. Okay, now suppose that now that is the normal case of work. That is the normal case of work. When you push the car or push any object, okay, and you use your force to let this object move displacement, that is the work. That is the normal case of work. Okay, now suppose that we have another guy. He will pull this box by angle. Can you see that here? He will use his hands, okay, to pull his box like that. Okay, now we have angle here, and that is the force. Okay, that is the force. Okay, this angle is theta. Okay, now what is the component of x for this force? That is F cosine theta, right? Now in this case, work equaled FD cosine theta. Okay, do you know, here also we should to be FD cosine theta. But how much is the theta here? Anyone know, guys? How much is the theta here between F and D?
0.
0, excellent. And cosine 0 is 1. Because that in this case, when the F parallel with D, we don't write cosine theta. But in this case, when we have angle between force and displacement, in this case we will write cosine theta. Because we have here, we have theta. Okay, now the first case, when they are parallel, W equal FD. Second case, when we have angle, W equal FD cosine theta. Third case, when the force perpendicular with the displacement. Like this guy, he will hold his bag and move for maybe for 1 kilometer or anything. Bad picture, no problem. Okay, guys, now for this guy, hold his bag. Now the force like that, and displacement like that. Now theta here 90. Okay, now W equal FD cosine 90. Cosine 90 how much? Equals 0. If you make it by calculator, you can find that. Cosine 90 equals 0. Because that in this case, the perpendicular between force and displacement, no force. No force. Okay, guys? Now we have 3 cases with the W equal FD. If they are perpendicular, if they are parallel, FD, and this one, it will be the biggest work we have. When the force parallel with the displacement, the bigger work we have, bigger work. Okay, and this one less than this one work. Okay, because here we have theta, and this one work is 0. That is the 3 cases of work do we have. Now we can say that we should to have force and displacement, and they are parallel, or we have angle between them. If this angle between the force and displacement 90 or perpendicular, it means no force. No work. No work. Okay, guys? About the unit of the work. Okay? Now, we said that work equaled FD when they are parallel with each other. Okay? Now, work will measured by joule. Joule, that is the unit of work, like energy also measured by joule. Okay, and F measured by what? Anyone remember, guys? F unit? Newton. Excellent. And D? Meters. Yes, excellent. We can say that joule equals in Newton meter. We can say that joule equals in Newton meter. To understand more about how much the joule is, okay, now how much the joule is, when you have an apple, for example, okay, and you will take this apple and lift on your head from your waist to your head, for example. Now this equal 1 joule. This work equal 1 joule approximately. That's the meaning of, okay. Also, guys, by the way, I want to tell you also, we have sometimes we have a lot of forces exerting in the same object. For example, we have applied force and we have fractional force. Okay, now we have two forces exerting this object, and you will push this object in this direction. Okay, now we have applied forces and frictional forces. In this case, work here, it will be the net work, and F here, it will be the net F, or the net force, I mean. Okay, now suppose that here we have 60 applied force and 30 frictional force. The net force equals, by the way, if we have a lot of forces, you will take the net force of the all forces exerting the object to find the. Okay guys, in general, all the problems about the work, very easy, very simple to answer, okay, because it's direct. We have W equal FD cosine theta, just it, very simple. Okay, now look over here, how much work done in vacuum cleaner pulled 3 meters by forces 50. Now you can realize that very easy. This 3 meters is D, and force here 50 Newton, that is F. Angle is 30 degrees, that is theta. You can realize that very easy, very simple. Now he wants work equaled FD cosine theta. Now F equals 50, D 3, and cosine 30, like that. Okay, by calculator equals 130 joule. Don't forget joule, please. Okay, most of the work problems will be like that. Very simple, very easy to understand and to answer. Look over this note, guys. This is very important.
لازم يكون بالمتر
Yeah, now
والنيوتن
the
نيوتن.
displacement or distance should to be meters. Look over here. Now he give you 180 grams. We should to convert from grams to kilogram. All units on your problems should to be in the SI unit.